What we're going to look at here is the idea of solving absolute value inequalities. We talked about absolute value equations, and these are going to be very, very similar. The first thing we need to make sure we do is we need to make sure that we isolate the absolute value. And this means if there's anything on the side with the absolute value besides the absolute value bars, that has to go. We have to move that to the other side. We're not going to focus on that a whole lot in this section, but we'll look at that more in class. The second thing we're going to have to do is we have to make two equations, or in this case, two inequalities. And the reason we have to do that is because when we talk about absolute values, we don't know whether we're dealing with positive or negative numbers. We're going to end up taking the original absolute value inequality and we're going to break it into two of them. One is going to be greater than, one is going to be less than, or greater than or equal to, or less than or equal to. So the key to this is we're going to have two solutions. And then we're going to have to graph a compound inequality essentially. Because when I go ahead and I graph this, I'm going to have something like x is greater than 5 and x is less than 7. I might have something like x is less than 2 or x is greater than or equal to 7. Things along those lines. So when I go ahead and I solve these, I'm going to end up with two solutions because I made two inequalities, and then I'm going to have to go ahead and graph these, and I'm going to have to put these into interval notation. There are going to be two special cases here, which we'll focus on more in class. But let's go back, and feel free to add more to the notes as we go along, but let's look at the two examples. Our first example here, we have the absolute value x minus 3 is greater than 2. Well, the first thing we're going to do is we're going to write down this x minus 3, and we're going to write down the 2. We're going to come over here, x minus 3, and now instead of focusing on 2, we're going to focus on negative 2. We're going to leave the first one alone. Notice I didn't change the x minus 3 at all. I left that the same. We're going to leave the first one alone. Leave it as greater than. This number got flipped over. It went to the opposite side of the 0. We're going to do the exact same thing with the symbol. I have one greater than, I have one less than. Now I'm going to solve these the same way I would have solved them before. X is greater than 5. Come over here, add 3 to both sides. X is less than 1. So now what I have here is a situation where I need a number greater than 5, a number less than 1. Here's a little helpful hint. In this particular case, I'm dealing with a greater symbol. You might want to think of this as a greater symbol. And the reason I say that is because if I look at this greater, this is an or statement. And that might help you remember that. And we said before about the or statement is most likely this is going to be circles with arrows pointing away from each other. If it's a special case, it might be all real numbers. When I go ahead and I graph this thing, I'm going to focus on the number 1 and the number 5. I want numbers larger than 5 or smaller than 1. So this would be my graph for this absolute value inequality. If I was going to put this in my interval notation, it's a circle bracket because it's greater than and not greater than or equal to. Notice that both of these are circle brackets. These brackets will always match because if we use greater than, we're going to use less than. If we use greater than or equal to, we're going to use less than or equal to. Let's look at the other example. Same idea here. I'm going to make my two inequalities. My suggestion is write them down. Notice the 2x plus 1 doesn't change. Keep the symbol. Flip the symbol. Little more work here, but not anything that's much harder. X is less than 4. Over here, I'm going to do essentially the exact same steps. Subtract 1, divide by 2. X is greater than -5. This is a less than symbol. Okay, so you might want to think less than. That might help you. So in this case, we're talking about an AND statement. So now we know we're either looking at no solution or the dumbbell. Put my -5, put my 4. I want numbers that are less than 4, but greater than -5. If I was going to put this in interval notation, it would look like this. We're going to look at more of these in class. Think about these two examples. Try to understand where we got the two inequalities from. Hopefully the solving makes sense. And then from there the graph and the interval notation.